Meet the MQ-4C Triton, U.S. Navy's largest unmanned aerial vehicle. Hunting enemy ships and submarines, transmitting target data to surface warships and fighter jets, and networking or transmitting targeting data across domains in real time are a few of the operations now being performed by the Navy's maritime-specific Triton drone. The Triton has been flying for several years, providing significant value, especially in regions like the Pacific Theater, where it's purpose-built to function in a maritime environment. It can rapidly change altitude, operate specialized maritime sensing and targeting technology, track moving targets on the ocean, penetrate through weather obscurance, and utilize special de-icing systems to ensure functionality across a wide range of maritime conditions. The Triton utilizes inverse synthetic aperture radar, an imaging technology that generates two-dimensional images of high-value targets by tracking movements at sea. Functioning as a maritime variant of its well-known Global Hawk drone, the Triton has for years been upgraded with longer-range, high-resolution sensing, data analysis, and transmission to enable improved targeting, computing, surveillance, and multi-intelligence reconnaissance. Now, working with Triton maker Northrop Grumman, the U.S. Navy has declared initial operating capability for its upgraded MQ-4C Triton. Triton has proven to be invaluable for the maritime patrol and reconnaissance mission in the Indo-Pacific. Now that the system has achieved initial operating capability, commanders will be able to fully leverage Triton's powerful sensor suite to detect and deter potential adversaries around the world, says Ro Colley-Bruner, director of the Triton program at Northrop Grumman. Since its early operational capability in May 2020, the MQ-4C Triton has been an asset in the U.S. Navy's Pacific Fleet, conducting maritime and reconnaissance missions in the U.S. Indo-Pacific Command Area of Responsibility. Leveraging all the lessons we learned from our first deployment to Guam, Triton is poised to bring significant improvements that will increase its effectiveness in the battle space, enabling our manned-unmanned team to maintain awareness in the maritime domain, Rear Admiral Adam Kijik, the commander of the Navy's Patrol and Reconnaissance Group, said in the service news release.
Aircraft off deck.
While the Navy has consistently maintained that the Triton is not an armed platform, the integration of a series of upgraded next-generation targeting technologies significantly enhances the platform's ability to support high-speed attack missions across multiple domains and vast distances. Given this, it does not seem beyond the realm of possibility for the Navy to eventually equip the Triton with Hellfire missiles, Maverick rockets, Hydra 70s, or even glide bombs. Advanced targeting and potential weaponization of the Triton would benefit greatly from the integration of new computing and command and control technology, as artificial intelligence-enabled algorithms could efficiently process incoming sensor data to expedite targeting. The technological enhancements to the Triton clearly indicate the Navy's commitment to expanding its Triton fleet in the future and sustaining the platform for decades to come. This may reflect a growing recognition that, despite its larger size and less stealthy characteristics, the Triton can leverage evolving technologies and specific attributes to significantly enhance its operational effectiveness and survivability against technologically advanced adversaries. Advancements in sensor range and image fidelity, for instance, now enable medium-sized and larger drones to operate with greatly improved imaging precision. This capability allows the Triton to effectively carry out missions at higher altitudes, making it less detectable to enemy forces. Additionally, command and control upgrades, currently a focus of the Navy, can expand the secure networking capacity of the drone, enabling it to operate in a multi-domain capacity alongside surface ships, fighter jets, and bombers, facilitating rapid exchange of time-sensitive data. Many of these developments suggest that larger, less stealthy drones like the Triton, initially designed for uncontested environments, are being adapted, upgraded, and enhanced to function in dangerous, contested, high-end combat scenarios. While the Navy is cautious in stating that the Triton will become an armed drone, the rapid integration of new targeting technology may open avenues in that direction. While the Triton already conducts significant targeting missions, recent innovations are enhancing its ability to track targets, relay information, and potentially engage in offensive actions. It's increasingly evident that with advancements in command and control targeting an ISR technology, a drone like the Triton may offer unique value in future warfare in ways that were not initially anticipated. A high-altitude surveillance powerhouse. The MQ-4C Triton, a remarkable high-altitude, long-endurance unmanned aircraft, exhibits impressive dimensions that contribute to its outstanding performance capabilities. With a wingspan spanning approximately 130.9 feet, equivalent to nearly 40 meters, and a length of around 47.6 feet, roughly 14.5 meters, its towering height of approximately 15.4 feet or 4.7 meters ensures ample space for housing its advanced sensor suite and payload systems. The MQ-4C can remain aloft for over 30 hours at an altitude of 55,000 feet, reaching speeds of up to 330 knots. Its primary surveillance sensor is the AN/ZPY-3 multifunction active sensor X-band ASA radar, featuring a 360-degree field of view. This radar is capable of surveying an astounding 2,700,000 square miles, 7 million square kilometers of sea, shoreline, or land within a 24-hour period, or 2,000 square miles, 5,200 square kilometers in a single sweep. Utilizing the radar in inverse synthetic aperture mode, the AN/ZPY-3 can identify targets in all weather conditions. The Triton can capture high-definition radar images and employ advanced image and radar return recognition software from the onboard automatic identification system to classify targets without requiring intervention from aircraft operators. Designed to be semi-autonomous to conserve manpower, operators only need to select an operating area for the aircraft and set speed, altitude, and objectives rather than handling manual controls. One notable feature of the Triton, which distinguishes it from the Global Hawk, is its ability to rapidly descend to lower altitudes. It's constructed with a more robust lower fuselage capable of withstanding hail, bird strikes, and lightning. Furthermore, it's equipped with anti-icing systems on its wings. When operating at lower altitudes, the Triton utilizes the Raytheon MTS-B multispectral electro-optical infrared sensor, also used on the MQ-9 Reaper. This sensor comes equipped with an additional laser designator, pointer, and rangefinder capabilities, allowing for automatic tracking of targets detected by the multifunction active sensor. The Triton's equipped with a modular electronic support measure suite similar to one used on the Lockheed EP-3, which can passively detect and classify faint radar signals. It possesses the capability to triangulate and geolocate these signals, enabling mission planners to create an enemy electronic order of battle profile or keep the aircraft and others out of the range of enemy radars and air defenses. Detecting and locating the source of radar signals is also valuable for identifying military vessels at sea for potential targeting. Another remarkable aspect of the MQ-4C Triton is its role as a network relay and data fusion center. It can receive and transmit messages from various sources around a theater of operations, even when they're not within line of sight of each other. The Triton collects data from ships, planes, and land sensors via various data links and fuses this information to create a comprehensive picture of the battle space, which it can then rebroadcast. This capability significantly enhances interoperability, situational awareness, targeting efficiency, and sensor picture clarity, while providing an alternative to satellite-based communication systems. In summary, the MQ-4C Triton represents a paradigm shift in maritime surveillance and reconnaissance, showcasing how a large, adaptable drone can evolve to meet evolving operational needs. Its growth in sensor capabilities and data processing suggests a dynamic role in future warfare, demonstrating that its value extends far beyond its initial design parameters. As the Triton continues to evolve, it stands as a testament to the Navy's commitment to expanding its capabilities, ensuring a lasting impact on naval operations for years to come.
Tower trade line is officer active at hotel. Trade line tower.
So I was like, this is how